Today in Geometry, Chapter 4, Section 3, we're going to talk about proving two triangles congruent by SSS, or the side-side-side congruence postulate. All that is saying is that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles must be congruent. Okay, so let's look at these two triangles, ABC and RST. Okay, it shows here that AB is congruent to RS. And then the two marks from BC mean that is equal to the side ST because it has the two marks. And then we have the three marks, that should be three marks right there. AC is the same as RT. So we have three marks here and three marks here. So we can write a congruent statement from that. We can say that triangle ABC is congruent to triangle RST. Okay, now you got to remember that you have to put it in the right order. If you go from A to B, then you have to go from R to S. Could we have written it a different way? Absolutely. We could have said triangle BCA. Okay, if we use triangle BCA, then we have to start with what corresponds with B to C, which would be S to T. So we would have S to T to R here. Just make sure that you write it in the corresponding order. Let's take a look at an example. If we have the diagram given right here where we have these two triangles, and the problem is to prove that the two triangles are congruent, then we're going to set up our two-column proof and see what we have that is given. Okay, the first thing that we see is that segment KL is congruent to segment LN or NL, and we know that because in the diagram it is given, so that will be our first step. So now that's a side that we have congruent to another side. Okay, that will be important. The second thing that we can see from the diagram is that KM is congruent to NN. It shows you that in the diagram. So we'll put that as our second step in our two-column proof, and that shows us that there is another side right there. So far we have a side congruent to a side and another side congruent to another side. So we have a side and a side. So we're missing the third side. Okay, so we need a third side. Well, the third side of each triangle is side LM. And we know that LM has to be equal to LM because it is itself. So we're going to use the reflexive property. So our third step will be that LM is going to be equal to LM. And that gives you your third side. Why can we say that? What is the reason for that? It is because it's the reflexive property. Okay, now we have within the body of our proof a side congruent to a side. Okay, that's our first step here. And then we have in the second step another side congruent to another side. And our third step is our third side to that side. So now we can write what we're trying to prove. Okay, that triangle KLM is congruent to triangle NLM. And why can we say that? By the theorem that we learned today, which is the side-side-side congruence postulate. Okay, whatever you're going to use right here for your reason in your final step has got to be someplace in here within the body of your proof. So for your quiz for this section, I would know what the side-side-side congruent postulate means. I would just write exactly what it said. Okay, which is if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Okay, that's the side-side-side congruence postulate. You'll have an amazing day.